Hello, I am Soyoung, and today I'm going to talk about the paper of a simple framework for contrastive learning of visual representations. Imagine of solving such puzzle to mesh animals. We'll solve it by detecting the picture of a cat on the left side and then search for a cat on the right side. Such puzzle requires recognizing an animal and contrasting it to other animals. Similarly, emotion can learn such skill with a technique called contrastive learning. Contrastive learning aims at learning representations by enforcing similar elements to be equal and these similar elements to be different. To learn effective visual representations without human supervision, self-supervised learning methods have been actively used, but they still cannot perform better than the supervised models. This paper proposes a SimCLR framework which not only outperforms the previous self-supervised learning models, but also the supervised learning models on ImageNet classification. SimCLR framework models the previous problem in a self-supervised manner with contrastive learning to learn visual representations without human supervision. This is the full architecture of the SimCLR framework, and I will introduce with a step-by-step example. Suppose that there is a training corpus of unlabeled images. Then we should first generate batches of size n images. Here I will take a batch size of 2. Then a random transformation function t transforms each example twice using a combination of simple augmentations of random cropping, random color distortion, and Gaussian blur. Therefore, here we get total 4 images. Each augmented image is passed through an encoder to get image representations which are Hi and Hj. The encoder can be based on any convolutional neural network, and the paper chose ResNet architecture as the encoder. The representations of augmented images are then passed through a nonlinear dense ReLU dense layers and projected into Zi and Zj. Then the similarity between the augmented images is calculated with cosine similarity. Now I will explain the loss function. SimCLR framework uses a normalized temperature-scaled cross-entropy loss. First, the augmented pairs in a batch are taken one by one. Then the probability of these two images being similar is obtained with the softmax function. Importantly, all remaining images like elephants, except the most similar image like cat in a batch are these similar images, and this can be regarded as negative samples. Therefore, specialized architecture such as memory bank is not required for negative sampling. Then the loss is calculated for a pair by taking a negative of the log of above calculation. Since the positions of the images are interchanged, the loss for interchanged pairs should also be calculated. Here, the numerator are different. Finally, an average loss over all the pairs in a batch is calculated, and based on loss, the encoder and projection head representations improve over time. After pre-training on the unlabeled images, we can either directly use the output of CNN as the representation of an image, or we can fine-tune it with labeled images for downstream tasks. Despite its simplicity, SimCLR greatly outperforms other self-supervised models. It achieved 76.5% top 1 accuracy on ImageNet dataset. Also, the performance increased as the number of the parameters increased. To sum up, SimCLR outperforms the previous self-supervised models, but it differs from standard self-supervised learning on ImageNet only in the choice of data augmentation, nonlinear head at the end of the network, and loss function. Also, the experiment result shows that larger batch sizes and more training steps benefit contrastive learning compared to the supervised learning. Thank you.